Welcome to Java Programming 3, Session 4. We're going to talk about build tools today. And in order for us to talk about build tools, we need to talk about the importance of the build tools and what they provide, why they're important, what's the problem that they're solving, and the tools around it, like Ant, Maven, and Gradle. The evolution in the Java pipeline for building software of good quality. Then we're going to focus with Maven. And I know that Maven might not be the newest one, and that's the reason why. Because Maven includes a lot of... It's kind of like a perfect middle ground. And that's why I want to teach that one to you, to let you discover then Gradle. We're going to talk about the config.properties. That's just unrelated to build tools. It's just a way to not really have hard-coded variables in your code. And then we're going to do a research project. And that research project is going to be essentially related to Maven and Gradle. Okay, so in this slide, I'd like you to look at the teal rectangle, the one that says project. And you might see that that project depends on the other pieces of software, which is H, W, and Z. From that project that say we got on Git, on our repository, and we generate a jar, the ancestors or the direct dependencies is project H, project W, and project Z. Project Z has no dependency, so that one builds normally. But then you start looking into W and H. And in W and H, they do have... H depends on K, which depends on nothing, so that one would be resolved without a problem. And then W depends on B, and H depends on R, which both of those depend on the light green X. And R also depends on L, which is depended by A, the purple A. So there are two dependencies in common, and just you need a better mechanism, because if you're going to be using library that relies upon library, that relies upon library, that relies upon library, you need a good mechanism for climbing up that tree and building all those structures without you having to try to compile it, then realizing that something is missing, then downloading that, then putting it in the right place, then compiling it, and then realizing that something else is missed by that. And if you did that, it would take you a really long time to set up your dependencies. So that's one of the problems. Managing dependencies, all the dependencies and all the dependency tree provided by a project. Second, the second issue that build tools help us with is that they allow us to define what we want to do according to the life cycle where we're on. For example, cleaning a project, that means removing every single dependency and starting from scratch. So if we wanted to just absolutely start from scratch, how would we remove everything? It would take a really long time to try to figure out which ones are the dependencies and then clean out everything and then start taking things through the pipeline of the clean, then into compiling, then running automated tests, then packaging that, and then verifying that the packaging is correct, then upload it or deploy it and execute it and test it and all those things. So there's a life cycle of the software development that needs to be handled, and build tools allow us to do that. There's a third problem, and this is something that has become a more regular practice in software development. And that is the continuous integration and continuous delivery flow. And for that, the idea behind it is that you release as often as possible as soon as you have a feature, because all the everything is robust enough that it will allow you to do that. So the moment that you develop, you send it to test. The moment that the test pass, then it's deployed, and then you continue developing, testing, and deploying in a cycle, which allows you to move fast, which allows you to test things easy, to have less moving parts. When you're waiting a long time to do a release, you might end up having some problems on your code because 2-3 people could be working on different things, and somebody might have delivered something incomplete. So doing a continuous integration and continuous delivery is something preferable. Okay, so now that we've talked about all these paradigms and all these things that are we're solving, I want to show a little bit of the evolution of the software that led us to this point. And there are some newer versions also for different languages, but this is I wanted to have a timeline that it's related to Java directly. So the first thing that we see here is Make, which was introduced in Bell Labs in the 70s. And it was just a series of recipes of how to compile the code. Doesn't necessarily say about the dependencies, but at the very least is the steps to follow to compile the code properly. And that was good enough, and it's still widely used for C products. Like if you ever download the Linux kernel and you compile it yourself, most likely you are going to be using Make. And Make has a format of files that it's called Makefiles. And we're going to talk about it a little bit more in detail. But that was like the most primitive version of a build tool. Then moving on, the Apache project in the early 2000s started the Apache Ant project. And a lot of projects are still being built with Ant. And it's okay. It's a decent tool. We're going to talk about it more in a second. But it also with Ant Ivy, you can manage code dependencies. So it is kind of like they started first with Apache Ant, and they realized that also you needed to manage your dependencies. So they introduced Apache Ant Ivy, and Ant calls Ivy, Ivy calls the dependencies, and it's still used, like I said. Then one of the limitations of given some limitations that are going to become more evident in a few slides. Then Maven, the Apache Foundation, also released Maven as intended as a replacement to Ant and Ivy. And we're gonna go really, really, really deep into Maven. And the issue is that obviously software and open source always encourages something better, something simpler. And that led into Gradle, which right now it's being used by Android and other projects, but Android being the more important one. Okay, so let's learn about Make. So Make was created in 1976 at the Bell Labs by Stuart Feldman, and it was just essentially intended for C or C++ projects. Well, C in that case, because at that point C++ didn't really fully exist. And it is written and maintained in C. Uses some macros to define rules and targets. And Makefiles are complicated, cumbersome, and sometimes really picky as far as the spacing goes. So they are not the best thing to maintain things, but it's still widely used in applications. Like I said, if you were going to use a Linux kernel, you most likely would be using make. So moving on to Apache Ant. Ant was like the first one that is on the modern tools, and it has some similarities to make, but it was written in Java, and became quickly enough, because it was written in Java and it was not using the tedious make files. It became a really, given the popularity of Java, became a popular build tool for Java projects. It had a small learning curve. It was quickly adapted for those reasons. And at some point, when you started having like bigger projects, people started to realize that XML is a really ugly format. And there's a reason why right now most APIs provide JSON formats rather than XML, as it was in the early 2000s. XML in the early 2000s was a popular thing. Right now, other formats are taking over. So XML is a little bit unmanageably big. And when you have a really long project, you end up having a long piece of the code base, or at least the characters that you've written, that are not going to be really expressing anything important. So your files end up being big, difficult to read, especially for newer developers that are jumping onto the project. At the time of release, Apache Ant didn't have a management package management software. And then Apache Ivy was released to complement that. It was then later improved to also include plugins as a way to extend it. So Maven was then released in 2004 as an improvement to Ant. And the thing about Maven is that it provides what it's called the life cycle. It's built into the software development life cycle. So what is that life cycle? Well, if you guys remember on this slide, essentially it provides a built-in mechanism of clean, compile, test, package, verify, etc. It's built into Maven. And it provides also some goals and targets to make it a little bit more flexible. The important thing that Maven did, and that was the first software that actually did it, and others who might be familiar with packages like npm or pip for Python, Maven was the first one to have the repository of dependencies to be downloaded over the network. And that was actually huge, because you could use just one build file without anything else being downloaded and just build your project. The cons is that it's still using XML, and therefore it's verbose and it's got a lot of text around it. So in that sense, it's very similar to Ant, the cons. And it's a little bit harder to use than newer tools. But again, the most important thing that it was introduced, it was just the capacity of calling each one of the goals and life cycles independently and handling them. One cool thing about Maven is that you can define inheritance on your configurations. So if you are going to have multiple projects that run similar, you can actually write just one parent, and then from that inherit into other children. What is Gradle? Well, Gradle, it combines the good parts of all the previous ones, and uses a programming language to define the targets. And that language is just either using Groovy or Kotlin, which are really not XML, but they're known as DSLs, which is like the language to call the building instructions and the construction instructions. So you can see that a lot of time also happened between 2004 when Maven was released and 2012. So we can see that the authors of Gradle learned a lot from Maven, from utilizing Maven and Ant. To the point that in such a small window of time, which is 2012 and we're in 2018 at the time of the creation of this video, in 6 years, even Google implemented it as a default tool for building applications into the into the Android OS system. DSL is designed to solve very specific problems, and because of the DSL being a programming language and not a descriptive markup language such as XML, the configuration is actually quite simple. And also, just as Maven, it has its own configuration. Also, just as in Maven, it has its own resolution dependency engine. So now let's go back to Maven, because Maven seems to be like the in-between. And the interesting thing about Maven is that once you learn Maven, essentially you learn Gradle and you learn Ant. So we're going to focus the rest of the class into learning Maven, and then we're going to switch the project that we're going to build to be built via Gradle. We're going to convert that Maven project into Gradle. So in order for us to understand Maven, we need to discuss the proper concepts of Maven. On Maven, what is a project? Well, a project is essentially the main unit of work. It's essentially what you're going to build. And that is defined on a project object model, which is a POM file. That it's all the metadata that it needs to be compiled that describes how everything is going to be built and run and deployed and go through the life cycle. And that's a file that is sitting at the root of the file system. Then there's a concept of the artifacts. The artifacts is just essentially something that is used, consumed, or produced by a project. So you can have different artifacts, which is sub-projects or binary distributions or things like that. You're going to be using artifacts to consume it, or you're going to be defining one through the entire project. The group ID is just the universally known identifier. And just like packages, it is recommended that you have a fully qualified name that distinguishes them from potential collisions in the naming. A good way of avoiding the name collision would be using a reverse domain name. So for example, in the case of UCLA, you could do edu.ucla.extension. Whatever extra project names. Then a dependency in Maven is just another sub-project or program that will be needed to be downloaded in order for the project to be built. A plugin is a tool that Maven utilizes for building one of the phases of the life cycle, or to perform, or simply just to perform a task in the POM. A mojo is a class that implements the plugin mojo interface that defines the implementation and the goal of a plugin. The snapshot is just a nomenclature that you can actually say that something is a work in progress and that you are not really releasing that to the public, but it's a very latest development version, and it's a nice practice to have into your artifact ID or your so you can or even your versions, so that you can communicate with other developers. Xdoc is a documentation format that Maven understands. An archetype is just a template to create more projects. And there are other concepts that I didn't really want to get fully deeply dive into. Just because I don't want to oversaturate you. I just have much more the interest of showing you what are the things to use the basic stuff. Okay, so what is the life cycle? In Maven, we've been discussing the life cycle of tools for a little bit in this project, but let's really dive into what it means. So in the validate phase, you just make sure that everything is correct and all the information that is supposed to be there is there. The compile part is just the part that actually builds the project. The test phase is just, it executes the proper unit testing framework and makes sure that all the tests are running and running accurately before the code is packaged or even deployed. A software that will fail the test phase will not continue into the other further phases. The package is just essentially a way to put it in a distributable format. And for those of you that use Mac or use Windows, an installer, for example, a DMG file or a PKG file in Mac is essentially a way to package something. In Java, we're creating them as jar files. The verify is just any extra integration test, just to make sure that everything is correct. And if you remember from our previous class, we have unit tests that just make sure that all the individual parts run correctly, and then you have the integration test, which is all the interactions between all those individual parts running smoothly. The installation is putting that into the proper repository, and it could be also uploaded as a dependency for other projects. And deploy is putting that into the final destination where it's going to be either shared or executed. Okay, so how do we go into IntelliJ and create a project that is that it's related to Maven? And let me create a new project. And I am going to select a Maven project, and I'm gonna I can select that I can create from an archetype, and I can just go into something like quick start. If I wanted to create from an archetype, I can just say quick start, or I can just go into the default vanilla idea. So in my version 1, you're going to see that the snapshot, because it's a work in progress. And we're going to create a project that uses FXML. And we're going to download a Twitter image from a profile. Just the idea is to have two completely different dependencies, and then bring them together to our package. So I'm gonna call it on my group ID. I'm gonna do edu.ucla extension.twit image, and the artifact ID, we're gonna call it twit image, and we're gonna save it here, and we have our basic project here. And you can see some of the basic structure was generated. Some of the test tools were also generated. And because we want to have a Maven, there's a tab here that it says Maven. If you don't see it, it's right here. Let me make my mouse a little bigger. It's right here. Right here. Okay, and then if you click on that, you're gonna see the plugins that it's running and the lifecycle. So I can run Maven build, and it's going to run the clean lifecycle here. If I run this project clean, and it just has cleaned all the basic stuff. This is a useful tool to have to control our Maven project. And in the structure here of the file, we have also our basic packaging and information. So if we want to say add a dependency, and let's say that we want to add our what's it called, the Java effects. So let me open up Chrome. Which, by the way, actually, I'm gonna do a little bit of a plug here. I have been using this browser called Brave, and Brave is a wonderful privacy tool because it allows you to not be tracked, and therefore your computer doesn't become slow. So I'm doing a little bit of a plug here, but I've used it because even my super beefy MacBook Pro sometimes becomes really slow, and I realize that it's actually because of the browser. So this has helped me a lot. So let's just go into Twitter, and then we're going to Java. So we're going to go into Java Twitter, and then we're going to find that there is a library. If we go into, like, say, the Twitter developer libraries, we can find some libraries here that allow us to be using be by different languages. So let's choose this Twitter4j, which is quite well documented. And since we're gonna be downloading this, usually here in that area that says how to use, you're gonna see what how to do it. So luckily it has a Maven integration, so we're just gonna grab the latest 4.0 dependency on Twitter4j, and we're gonna copy this dependency tree, and we're gonna put it into our dependency section. So if I click this little arrow here, I mean this little recycle button, which if I leave it here, you can re-import all Maven projects, and in this one with a blue recycling in the folder, it generates sources and updates the folders for a project. So at this point we can see that some of our dependencies are in that. How do we know? Because if I create let's create a new package for me, package edu.ucla extension.twit image, and here we're gonna create a new Java class, which we're gonna call it our main class, and extends application, and we're gonna use, is it application? Yes, it extends application. And here we're gonna, no, I don't want that one. Application. We want the Java effects one. Oh, it's not there because, let me explain something. On my project structure here, Java 11 decided that that Java effects was not going to be shipped with Java 11 anymore because it was holding back Java effects. So they removed that that thing inside, and then they added it as its own separate project. So right now we're not gonna really extend it, but what I do want is to prove that import Twitter4j, or what does a class look like in just a very basic example. How to use source code. Let's look at the source code. I think it's no. Where is just a quick sample? Code examples. And where do we have import? Oh, I think it's import Twitter4j dot star. So right now Twitter4j is not showing. So if we make sure, oh yes, the moment that I click this button, which reimports all Maven projects, it brought this thing here. So right now it's not red anymore. That means that it's part of that. Okay, so we discussed also that JavaFX is not really part of Java 11 anymore. So how do we bring it into our dependencies? It's the same way that any other Maven dependency. We can find a dependency. Okay. And we add another dependency. Oh, what is going on? And then we close this dependency. We add a new dependency in here, and we add the group ID, and then we also add an artifact ID. And you can see how all these things, like even if I go into Command N, I can actually add a new dependency here, and I can start looking for some other dependencies in the system. But right now I'm just adding it by hand. And version. So we have the very basic things. We're gonna do the we're gonna look for the group ID, which is org.openjfx, which is the holder. If we go into openjfx, is the holder of JavaFX now after version of 11 of Java. And ideally we want to import the JavaFX fxml, and this is probably because in another project is being used, but let's use 11.0.01, and let's click this, guys, to be auto imported. And now we can go back and do extends application, and guess what? It's still not there. So we need to then add the basic OpenJFX stuff, which we're gonna say the controls is the other one. So let's go back and see if now we get JavaFX application, which is part of the control. So we need to, in order to bring JavaFX, we need to import fxxml for our XML and our Java controls package. So we have our main class, which is extending application, and this thing is, in order for it to be an actual application, it's complaining that it needs to be using the start stage method, which if we do Alt Enter, we can say that we're going to implement the methods because it's an abstract class, and it created the methods for the stage. So far it's been compliant. It's been looking good. So our actual project, if you guys took Java 2 with me, which eventually I'm going to upload all the videos for that, we are going to just create an fxml path for our, where we're going to put an fxml, which I'm going to create then in the, you can see here, there's a resources folder generated by default by Maven, by the Maven tree structure. If we, it's probably a good time to segue into this. Inside of the POM file, we have these following top level XML structures. We have our packaging, which you can define how the file is going to be packaged and outputted. You're gonna describe the dependencies, other properties that you are required to understand the basics of the file, how the project is going to be built, repositories, where to look for some of those dependencies, and certain profiles to change the capacity of changing how the environment is going to be run. Once we create a Maven project, you're going to notice that there are these directories. It's going to have a source main Java, which is where the source code for the Java files are going to be. A source main resources, where other files that are not Java classes are going to live, such as an fxml or a config properties file or something similar. You're going to have other folders like filters or web app, but those will become more familiar later as we build some tools further down this quarter. In there's going to be a subfolder of source called test, and you're going to see a similar structure which has Java, test, and resources. And the idea of those is just resources and files allocated for unit testing or integration testing. And the source IT is actually for integration tests, primarily for those plugins. Okay. So here's a list of basic archetypes for whenever you create your project. And in these archetypes, you are going to find that there's, there's like the Maven archetype, which is just a template, and it's just going to generate a sample file. Then you can have some that are related to J2E, the Enterprise Edition of Java, and it's just basically going to generate a plugin under those conditions. I mean, a template under those conditions, a project with a template under those conditions, and etc. So this is so let's then go back into this later. So in here, we're going to then define where we want to load our XML file, our sample XML, fxml file. So if we generate our, let's call it a file, fxml file here, and we're going to generate it, and we're going to call it main.fxml. And in the, as you can usually see, it pre-generates everything. FX controller is main, but in this case, because main is inside of this package, we're going to do edu.ucla extension.twit_image. And actually, I don't want to do it on the main file because this one is just executing the Java application. So according to what best practices and what we saw on Java 2, we're going to split it into the model view controller. And I think I have a video for that. If so, I'm going to leave a link here so you can look at that class. So we're going to point into a controller where right now it doesn't exist, so we're going to generate just a new Java class, which is going to be a controller. And now our fxml file, our main file, is pointing to a controller. Inside of that scene, I want to put, this is the size of our scene builder. And here I am going to put an image in the controls. Now, once I go into the scene builder, I'm going to go into the image view. Oh, I'm going to put an image view. And that's the only thing that I'm going to put right now. Image view. Let's just put it here on the hierarchy. Oh, no, it's not this. It's this. And now we have an image that is sitting there in our fxml file. And because we do want to reference this via the controller, we're going to call it just image view, and eventually we're going to go into our controller and do fxml, and we're going to just reference fxid equals, oh, and we're going to put like image view, and we're gonna tell it the image, the thing named image view on our image or on our controller is gonna reference this via this annotation, is gonna reference this guy here. So right now it's complaining that it's not seeing them, so we're gonna import alt enter, and that imports Java XML, FXML, and then the annotation. This guy is the same thing. Alt, enter, and we have now a file that is compiling. So now then we just got a link as a usual FXML project. We're gonna main.fxml, and then FXML loader. And for creating this guy, we're just gonna say I don't want to have to put the full path of like my home directory. Like if I see this open in terminal in my computer, it is this full path, and I don't want to do it this way, because whenever I send it to another computer, it's gonna look for this file and it's gonna crash, because in your computer your file has a different thing. So what I want to do is to reference the path from where I'm executing this. So by doing the get class dot get resource, and then I pass my FXML path, if I was going to say like get resource is going to return a URL. So I can pass it as an argument to the FXML loader. So let's just run it and see how it's actually working. Well, right now, main doesn't have a main method, even though that it says run main. It's not going to do anything because there's no really a main method, because it doesn't have, yes, there's a little trick with FXML. I mean, not with FXML, with Maven, that when you have your compilation stuff, you need to put the right version for this. So we're going to we're gonna tell the build side of things. No. Well, let's go back. So right now we don't have an entry point for this. So we're gonna do a public static void main, and we're gonna do a string args and an array, just our usual entry point, and let's just out.println entry point. So right now our FXML has no way of building things. I mean, it has like the inherited given the schema that it followed, but let's just define exactly what we wanna do. And given some the compiler plugins, which is, we're gonna see that it's doing this guy here. So I'm gonna then do a build, and then actually I can try to just run compile, and then we're gonna compile our thing. So it's complaining that our POM file has an empty build, an incorrect build tag. So it's this character. So now let's just run our compile method. And now it's complaining that the target option is not longer supported. Use 1.6 or later. The quick way of fixing that is by telling our plugin. So if we do a plugins thing, and we add from a plugin template, if we say on our plugin, and we're going to use the same one, we're just going to override the Maven compiler plugin. So we're going to do the same things, which is org.apache.maven.plugins, And the artifact ID is going to be Maven compiler plugin. And we're going to then say that the version of our plugin is, which one do we have? We have 3.1. And in that version, then we want to configure it, because clearly it's not liking this option that the compiler is passing. So this is a quick hack. You don't really have to, I don't want to really like spend too much time on making you understand this. It's just, this is a way that you can fix it by doing source, and then we're going to say 1.5, target 1.6. And with that, we're essentially saying that let's use 1.6. So if we right click and compile, that error is no longer existing. However, the source 5 is no longer supported, so let's use 1.6. So let's just change for 1.6 the source. And now it finished building successfully. It's just some parameters that the compiler, the plugin actually needs. So we're just telling it to use a newer version. Okay. So that's kind of cool and everything, but if I want to run it, actually, let's just say run main. It's gonna complain that a bunch of other stuff, because I went and ran it via the traditional way. Because at this point, the project is not really configured to be run via IntelliJ. Is configured to be run, built, and executed via Maven. So we need to tell Maven how we're gonna execute the program. And I'm not gonna waste a lot of time on writing the code here. I'm gonna point you to the URL where the full project will be. But I just wanna discuss how some of these things were added. So in my POM file, I have my build section, and what I want to do is that I want to override the deploy, because I'm not going to push this application to a server. I'm just going to run it in my machine. So I want to override this deploy lifecycle phase and override it with my own runtime. So what I'm going to do is that I'm going to, and here in the plugins area, I'm going to press Command N in Mac, and I can say that I'm going to add a plugin dependency. So it made like the template here. And yeah, let's enable auto import, so that way we don't have to be pressing this guy every time that we use something. So I'm going to use the org.codehouse.mojo plugin that it is named exec Maven plugin. And as soon as I specify a version, right now it's trying to look at it and it's like saying one error is found. So if I click on this, it's going to say that the error is because it's not really has a version. So the easiest way for me to find it would be by going into my browser and say Maven exec plugin. And if I go into the Mojo house, we can find the Maven, how to use it. And you can see how it's some of the configuration. But if I want to, here it's actually telling me the version of it. So I'm going to use the version 1.6.0. And it's going to be read for a second until it actually imports it. Actually, I can force it like this. Come on. It's not going to find it if I spell it wrong. So automatically it downloaded it. And now I just got to tell this thing how to use, because if I keep running this, in no part here I'm telling it, hey, overwrite the deploy phase. So then I just gotta tell it then that, and actually there's a build failure saying that the goal deploy repository element was not specified in the so we're not telling it what to use to deploy. So after this I'm gonna add the execution, and this can support many executions and then a single execution, where I'm just gonna say in this execution what is the phase that we're gonna use, and we're gonna say that the deploy phase, which is this guy here, we're gonna put it right here, and we're gonna define the goals to run with that thing. So I'm gonna call the goal, well, let's not define the, let's see, right now it's just for the deploy phase, we're gonna do that. And then after the executions, then we need to say how we're gonna run this. So we're gonna add the configuration session part of it, and there we're gonna say that, oh, if I was gonna run it just like that, after that it's gonna complain that this plugin, where is it? That this plugin this plugin is trying to run instead of this guy yet. So we're telling it, yes, run it in deploy, but still after that, then this guy is, before that is trying to run, and then this one would try to run. So we need to tell this plugin, the deploy plugin, that we don't want it, because this is, I'm inheriting from a configuration that already exists, and that's the default in Maven. And that's why all these plugins already exist, because I'm already, you don't see them here, but it's already inheriting a configuration of that. So in our build phase, we're gonna add a new plugin phase, and we're gonna tell it that this guy, the org Maven plugins in the group ID, and this guy here with this version 2.7, we're gonna then tell it that on our configuration, we're gonna tell it to skip, and then now that we tell it this guy, the built-in configuration to skip, it's gonna try to run this other guy here. But now that it ran this guy, we haven't really told what to execute. So, or what is a command to run. So for this guy here, we need to add a goal, and we're gonna add the goal of execution. So we again go ahead and run it, and now it's saying, well, you're trying to execute something, the execution goal that it's built in with the Maven plugin, the exec Maven plugin. So we're saying in the phase deploy, go and use the execution goal, which is this guy here. These are the goals that are available for this help, Java, or whatever. So we can actually even do Java here and just run it. And the parameter main class, it's complaining that the parameter main class is really not there. So we can add main class as an argument in the configuration and say org dot edu.uclaextension.twit.image.main, which is the path to this guy. And if we run it again, it's saying that it's executing this guy. And you can see here in entry point is doing the entry point. In the source code example, I am using something slightly different. I am calling the goal that is exec because I want to execute Java and I want to pass other parameters. This is just for you as a reference to understand that you can pass certain other parameters to the program. But since the exec of Codehouse has the goal of either help, exec, and Java, in this case, I am executing the Java, so it's calling Java and then the execution of this program. So you can see here, there's an entry point, which if I was going to do like just a traditional launch args, is going to then run our deploy. And you can see that it actually is running something. The application is running, but it's not really displaying anything. So why don't we create just a quick window and then say parent root equals loader dot load. This is from JavaFX, so I'm not going to spend too much time on this. We're going to create a primary stage dot set title, my title, and oh, not primary stage, it's just stage, and stage dot show. For now, let's just try to run it, stop and rerun. And in this case now it's complaining that an exception occurred while executing the Java application. The method location is not set. And that is on our main 15, which is this guy. So I'm gonna just skip the parent for now, all these guys. So let's just, for now, and run it again. And now we have a little window, but with all of the other dependencies being called. Pretty cool, huh? So about code hygiene. What does that mean? Well, I cannot be, like I was saying earlier on, if I go into the console here and I try to like reference my XML loader. Oh. If I try to reference my XML path, I would do source main source main resources, and you can see that my XML file is there. So if one second, please. Much better. So if I am referencing my object here, my fxml file, a good way of doing so, or trying to find it without really getting to the entire thing, I'm gonna just do a system.out.println, and I'm gonna try to reference the path of my fxml path. So I'm just going to copy these two lines here, and I want to let's just do it here inside of our let's do this guy here, and let's just decouple it and say URL path equals this guy, and we're going to import the URL and just say print path. And honestly, I don't want to do anything else other than setting up the title. The same thing. So my entire goal is to print the full path without really having to go and type all my entire directory tree, because when I send the file into another file system or somewhere else, it's not going to work. So what I need to is to decouple that thing and just have a reference, a real reference to it. Doesn't matter where it lives. So if I run that path, you can see that here, where's my, for some reason, is saying that it didn't find it. And the reason it's not finding it is because it's in a different directory. So I'm going to put it in here. So it's inside of resources rather than resources of fxml. So I'm just going to make it match. I'm going to create my directory here called fxml. And I'm going to move this guy here. And now, theoretically, because it did find it, it should print something else other than null. So let's just run that guy again. And now it's pointing to a file that it has, that it goes directly into that file. So that's a good code hygiene. So if I now, even if, say, I want to make it fancier, if I want to make it fancier now that there's this image, let's just add a label that has, so that way you can see that that it's being read from this guy in here. And I'm gonna just say the text for this is JC teaches Java. And let me move this guy more outside. Okay, so now we have this guy. Let's make it a little bit of a, let's make it a bold font and a little bit bigger. Okay, cool. So now you're going to see that if I deploy it, it should run that. Yeah, stop and rerun. It's going to show that window. Location not set. Ah, yes, didn't pass this argument. So let's just pass that argument. That's why it's important to do that. And right now it's not showing anything because I got to add into the stage the scene. So I forgot something like that. I forgot that. Good thing that we can debug scene, and then we're going to do new scene, the root, and then we're going to say that this is going to be like 500 by 500. And then just deploy it. And now that we have a root, you're going to see JC teaches Java. So, okay, I decoupled those things. Great. In reality, you're not seeing that I'm putting a full path, and I can then send it to you, and it's going to execute properly in your machine, and then you're going to send it to your friends, and then it's going to execute properly in your machine. So that's a good code hygiene, not assuming that the running environment is going to be the same everywhere. So you got to account for that. And most importantly, don't hardcore variables. Most importantly, don't hard code variables. And the thing is, for that also, it's important for API keys or things like that. So one thing I want to talk about, since we're talking about resources, I want to add a new file, say that we're going to create a config.properties file. And here I can just put a bunch of different variables that I can put in a key value pair file format. So say, let's say these are my properties. And I can then say, like, I don't know, API key. And let's say that because this was going to be Twitter, I can do like an API key and then put whatever 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you know. And then I can put the secret. And let's just put random stuff. in this case, I mean, I'm just emulating as if I had gotten a key from Twitter. And so on. If I'm using different services, like say I'm grabbing something from Twitter, copying it onto Facebook, I need an API key from Facebook, and I need to put it also into this file. So a good way of then not keeping, those keys being propagated by the entire file and everything is that I can, when I am creating an object or something like that, I can create a little class that I can call like config reader, and I can do so I'm gonna load these because it's a key pair value. The most proper data structure to use would be a hash map. So what I'm going to do in that config reader, I can do public static, because I don't want to even have to instantiate a config reader. Actually, here it would be really good to do a singleton, so that way I only instance it once and I don't keep accessing the same resource all over and over and over. So I'm going to do a private config reader, and I'm going to put a private config reader instance. So here, then public static void config reader get instance, and we're going to use here the method for doing like a traditional singleton. So if instance private static, because we're going to hold it at a static level. So if config reader, if instance is null, then instance equals new config reader, and then return instance. Boom. So we have created that. And inside of our constructor, then we can also, well, here we can do public or private public hash map, and we're going to say that it's going to be 2 strings because it's going to be a key value pair. And then we're going to say config or values, or config. Let's call it config, so that way it's a little more standard. Here we're gonna do like something that that we are going to then just read a file by saying we're gonna do an input stream reader, input stream reader, or is equals null, and we're gonna put a properties on the Java util prop equals new properties, and here then we're gonna try to then string prop file equals config.properties, and then we're gonna properties, and we're gonna do the same thing that we did for the fxml. We're gonna use URL file name equals get class dot get resource, and then we're gonna call it the prop file name, and we're gonna import this guy here. We're going to input an input stream, and we're going to create a new we're going to create a new enumeration. Well, let's look at how prop files, when I read it, like I can do something like prop, which is our load, and I can put the input stream, which is is. And also here actually I can change it as that resource to be an input stream prop resource, and let's just as stream and then pass a prop file. Now it's going to return it, instead of just the path. This is actually going to put it as an input stream. So let's just reference it as is. And we're loading this guy. So now it's complaining because it doesn't have a handled IO exception. So let's just tell the IDE that we're going to surround it with a try catch. And then we want to get the prop.keys. And the prop keys is going to, and let's see if there's an iterator. Let's see. How do we get all these guys? Property names, enumeration, replace all size, store to XML. We're gonna have to string property names. We can use string property names, but I'm gonna just use the keys just to access it directly because we know that it's a key value. So actually I'm gonna then save it as an enumeration object, which is what this guy is returning. So I'm gonna match the data type, and then we're gonna call it keys because it's just a shortcut for this. And then while keys has more elements, we're going then to, in our we're going to extract the string key equals keys dot next element, and we're going to try to cast it because it's expecting an object. Actually, we can do a string. Let's see if it automatically. Now let's just cast it here because we know it's going to receive a string. So key and then string value, we're getting the key from the element because we're iterating over the keys. Keep an eye on this. We're going through each one of the keys, meaning that if we had its Twitter key, Twitter secret, so that's what we're iterating over. And the value is going to be the prop.get, and this is where we're accessing the value of the key, but we're going to say like get property. We're going to use this guy because it directly puts it as a string. So we're going to get the property for the key, and then we're going to pass it to our, where is this guy? Config dot put prop dot put key comma value. Okay. And with that in mind, now that we have this guy, let's see where it's complaining. It's complaining somewhere in here. It doesn't have a semicolon. So with that in mind, if we went and did this, we can then put just our system before anything else. We're gonna call this just config reader cr equals cr dot get what is it called in this method? Get instance. Config reader get instance, and then system dot out dot print ln. We're gonna just verify that our config that our hash map is being read properly. So we're gonna run it, and something is failing. So exception if an application is on config reader line 23 and then get instance 38. And in stream is parameter null. Where is in stream? Did I leave something that was in stream? No pointer exception. I suspect that it's somewhere in here. So we didn't put it's a get class loader. There you go. Which is not exactly what it's. Where did it go? Where did it go? So let's run it. Let's see. It's still complaining. So it's I suspect that it has to do with this thing, which prop file. Let's just convert it into the traditional thing. So prop input stream equals new input file input stream, and we know that file input stream can finally, we gotta close this file. We're gonna file input stream, and the constructors could be either the path or file descriptor or file. So we're gonna get just a path by saying URL prop file URL equals get class get resource prop file. And before we pass it, and we do this as get file. Before we do this, we should do system.out.println and just say prop file URL. And in this case, it probably needs to be surrounded with a try catch. So to put it all in the same context, I'm gonna put it right here, and that way. Let me just make it a little bit bigger. You guys need more of this than the other thing. And it's still failing. Don't you love when something fails? Compilation failure. Java IO exception must be caught in line 38. Yes, because this guy is supposed to also have surround with another try catch. So it's a try catch inside of a try catch. Best practices sometimes are ugly to implement. Okay, it's failing again, but at the very least I think that you guys are getting like a it is a null file. So config.properties. Come on. Config.properties. And if we copy the same thing here, let's see what we did here. Config reader. But it's just config. Rename. Just so we know that we're copying the value of the file exactly. We should put like this. / So the file is being now found, but for some reason we should try to add an exception for this guy so that the program doesn't fail and we know exactly where any other exception, and just add it. Just we're trying to like troubleshoot why this file null pointer exception. Sometimes constructors are a little tricky. So what we're going to do is that we're going to move this method into private init. We're going to just call it an initialization method, private void init, and then we're going to do this, and then inside of the constructor we're going to call an init. And let's see if once we take it out of the context, if at the very least the stack trace gives us a better idea. Yeah, get instance 56, man, 37. So I know why. And this is me just being absolutely silly. It's trying to put, now I see it clearly. It's line 37, which is trying to put something that hasn't been initialized, values into something that hasn't been initialized. That's why it's giving us a null pointer exception. So before we do this, we should do config equals new hash map string string, and now we can actually execute it. Ta-da! And with that, we go into our challenge, which is, I would like you guys to download the source code for the full project of this, get an API key, and then execute it, and then convert it into Maven, into a Gradle app. And I would like to get a screen grab, and the Gradle configuration, the screen grab of your project running, and the Gradle configuration uploaded into the URL of your Git project, now being uploaded, forked and uploaded, now with a modification of Gradle, and a screen grab that you were able to run the project. Okay? All right. I hope this was useful. Talk to you later.